Okay, so for our last example and our example of contour map, we're going to return to our example of the paraboloid. So let's try to remember what this looks like. So x, y, and z. It looks a little bit like this, right? Some parabola opening up both on the z and the, or rather the yz and the xz axis. This looks like a parabola. And in 3 dimensions, it looks like a parabola that's spun around the z-axis. Looks something like this. If I wanted to know what level curves for this looked like, I might be able to draw these things. Maybe let's draw them in a different color. Let's say we'll draw them in blue. So if I wanted to know what level curves of this look like, these are the level curves. In fact, this is what we drew before to try to kind of help us draw this thing, right? This might be z equals 3. This is z equals 2, and this is z equals 1. This is very not to scale, of course. But if I wanted to know what these looked like, these are level curves. If I wanted to know what these looked like, and maybe even on just paper, get a sense for what this function might look like in 3 dimensions, then I could graph these things, right? I could graph, let's be a little bit careful here. Let's say that this is x equals 1, and here's x equals 2. Give yourself lots of space here. So I have here z equals 0. That's my first level curve, or rather my first contour here. I have z equals 1, because at z equals 1, I have x squared plus y squared equals 1. At z equals 2, I have x squared plus y squared equals 2. That's a radius approximately 1.4, approximately 1.5 even. Let's just say it's 1.5. So we have a circle here. These are all concentric circles. It's not going to be to scale. Z equals 2. X squared plus y squared equals 3. That's a circle of radius approximately 1.75. So we're getting a little bit closer. Everything's getting a little bit closer as we go out. This circle's just a little bit closer to the one inside it. Z equals 3. And then finally, let's just draw this last one. X squared plus y squared equals 4. And that's going to be a little bit closer. These curves get closer and closer and closer as z gets bigger and bigger and bigger. Although it may not look like that in the graph. And so I'm maybe just above this, I'll just draw what this is coming from. It's coming from something like this, right? Maybe. Right? It's coming from a paraboloid. And some things I want to notice. So this is what we were asked to do. This is a contour map, right? Things I want to notice. As curves are closer together, the function changes more rapidly. Right? And this actually, I mean, this should make sense, right? If this was a mountain, if this was a topographical map, then lines being closer together means that the change in height is much quicker than when they're farther apart, right? If I was trying to find a path up Lonesome Mountain, I might look for curves that were sort of farther apart, so my walk was a little more gentle. If I wanted to get right up there, then I would go up the steepest slope. We'll look at a lot more examples of these in the workshop, but that's sort of the idea here. This is sort of our first glimpse at what a contour map tells us. All right, thank you. I'll see you guys on Thursday. We'll definitely work on some problems from each of these definitions. Watch the videos until you sort of understand what's going on. I'll post the worksheet too. You can start looking at some of the problems and see if you understand them. Okay? Thank you very much. Have a nice day.